So let's look at an example to understand when and why we might use Z. So the typical use of Z is to identify outliers, to calculate a Z-score and identify whether or not something is an outlier. So let's look at the case of scores on a math exam, right? They're normally distributed with a mean of 100 and a standard deviation of 15. Our buddy George here obtains a score of 112, right? So he's above the mean. So the question is George of typical ability or is he something special, right? So we know he's above the mean. The question is he so far above the mean that we would say, wow, there's something going on here, right? This is an outlier from what we would expect. Well, the way we do that is we calculate the Z-score around George's particular score, right? So we know the formula for Z is X minus M, or the particular value minus the mean over the standard deviation, right? So X over minus M tells us how far away from the mean the particular score is. And then we scale that by dividing it by the standard deviation to tell us how many standard deviation units that represents. Right, so we know that in this case, M was equal to 100, and SD is equal to 15, and the X for George is 112. So we can see that 112 minus 100 is 12. So this tells us that George is 12 above the mean, right? If it was negative, we would see that George is 12 below the mean, but in fact, George is 12 above the mean. This is the distance, and then we scale that by dividing it by the standard deviation. So 12 divided by 15 is 0.8. So Z for George is 0.8. Another way of saying this is that Z is 0.8, George in this case is 0.8 standard deviations above the mean. Right, if he had a score of 115, he'd be 1 standard deviation above the mean, but he's only 0.8 standard deviations above the mean. So now if we want to know if, okay, he's certainly not at the mean, so does that make him atypical? Well, if we say what percentage of people are less than 0.8 standard deviations above the mean, 84%, right? So he's in the 84th percentile. 84% of people scored lower than George did because we know he's 0.8 standard deviations above the mean. What percentage of people are more than 0.8 standard deviations above the mean? Well, just over 21% of people scored higher than George did. And now to get to this typicality question, what percentage of people are more than 0.8 standard deviations above the mean or 0.8 standard deviations below the mean? So they're in those tails that are outside of 0.8 standard deviations above or below the mean. Well, it's really 42%. So 42% of people are above or below that 0.8 standard deviations away from the mean. And so it turns out most people are within 0.8 standard deviations of the mean, right? And so it's like 58% of people are within 0.8 standard deviations of the mean, which would tell us that George is probably pretty typical, right? Because most people, certainly more than 50%, like 58%, are right around the mean, or at least within 0.8 standard deviations of the mean, like George. So, okay, how far though is too far, right? So we can say, okay, a p of 42.4, 0.42, that probably says, yeah, it's pretty typical. How far away would George have to be before we would say it's not very typical? And that comes from just our ideas of percentages, right? And so if we think about conditional percentages, we think about flipping a coin. If we flip a coin any one time, the likelihood of getting heads is 50%, right? Assuming it's a fair coin. Now, if we flip it a second time, it's still 50% of getting heads. And we flip it a second time, it's still 50% of getting heads. But the chances of getting these in a row gets to a question of conditional probability. The chances of getting heads once is 50%. The chances of getting heads after just getting heads is 25%. So the chances of getting head twice in a row is 25%, because first there's a 50% chance of getting heads at all, and then there's another 50% chance of getting heads a second time. So now it's only 25% of getting heads twice in a row. 3 times in a row is 12.5%. 4 times in a row, 6.25%. The likelihood of getting heads 5 times in a row is 3.125%. If we got heads 5 times in a row, we'd start to say, that's probably not a fair coin. And it's right here between the 6% and 3% that we start to say it's too far. In fact, we usually say around 5% is our threshold for when we start to care. When we say if you have a less than 5% chance of getting a particular response, that's probably not typical. There's something systematically interesting going on. So if we go back to George, right, M equals 100, SD equals 15. George had a score of 112, which was a Z score of 0.8 or 0.8 standard deviations above the mean. So what percentage of people are more than 0.8 standard deviations above the mean or 0.8 standard deviations below the mean? 42.4%. So if I go back to my just the discussion I just had about, well, if only 5% were in those tails, right, above the mean or below the mean, then that would tell us that somebody's atypical. So what Z would George have to get that is atypical? Well, if you remember back, 1.96 standard deviations above the mean and 1.96 standard deviations below the mean, the amount in the tails then is 5%. So for two tails, there's 2.5% of answers are above 1.96, 2.5% are below 1.96. So only 5% of people scored above or below 1.96 standard deviations away from the mean. So what score would George have to have gotten to be within that group at least? Right, so a Z of 1.96. So if we know that Z is X minus M over SD, we can just do a little bit of algebra and we can see that I can calculate X as Z times SD plus the mean. So in this case, 1.96 is that critical value of Z when we be kind of too far away, times 15, the standard deviation here, plus 100, which is the mean. So 129.4. If George had received 129.4 on the exam, we would say he is of atypical ability. He is very far from the mean because he is now at least 1.96 standard deviations away from the mean. And we know that only 5% of people are at least 1.96 standard deviations away from the mean. So if he'd gotten a 129.4, we would say he is atypical. He's very far from the mean. Because he's actually score is 112, we say actually he's typical. We can't say that he's not typical because he's only within 0.8 standard deviations of the mean. So look, this can be hard to wrap your head around. I recommend taking a look at this and maybe some other videos about how to do it. But this idea, what I really want you to understand is that Z tells us how far away from the mean we are. And once we understand how far away from the mean we are in terms of standard deviation units in a normal distribution, we can apply some percentages to that and some percentiles to understand the likelihood of getting such an extreme response. And this is all based on this normal distribution and understanding how far away we are from the mean and how typical that is.